Cool.
So,
wow. All right, I'm going to get started. Thanks for coming. We actually have a lot more people that are online. So we got three people here and like 14 people on Zoom, 15 people. So that's nice. So one of the things I wanted to start off with was the audio. Let me know if the audio is not loud enough. I got a little mic right here. There's a lot, 50 cameras going around here. And so I think instead of like raising your hand on Zoom or anything like that, feel free to just unmute yourself and, you know, pop with a question. And I won't, you know, that's fine with me. Yeah, so is everyone on Zoom hearing me?
yes.
Yeah.
Okay, thank you. Yeah, so I've got one mic set up over here and this one's like no volume. There we go. Don't want any feedback. All right. So today's presentation is about test-driven development, specifically in Python. I'm introduce myself. I'm Gene Payne. I'm a software developer here at SCI. Looks like we have a lot of people from, some people from SCI and others from outside, maybe other organizations on campus. That's great to have you. I'll start with, this will kind of be just an overview of what test-driven development is, how it can benefit you in software development, and then we'll get into some Python specifics. So this might be kind of a boring intro for some of you, depending on how much you know. But I'll start from the beginning. So test-driven development was a part, it was added to the Agile software practice. I believe it was about 20 years ago or so when this Agile process manifesto was officially kind of put together. As I recall, or as I've heard, it was like actually here in up the canyon in Snowbird, Utah, where they had this conference and a lot of contributors kind of came together with different ideas and it gelled into this one practice. There were, like I said, a number of contributors, but Kent Beck was the primary contributor for the test-driven development idea. So it's a practice of writing unit tests first and production code second in order to pass the test. So it's backward from what a lot of people are familiar with, kind of maybe the traditional way of doing software. But it has a lot of advantages of doing it that way. So let me back up and go to testing kind of as a overall view, starting at a high level at the top and drilling down. System testing is like the whole monolithic piece of software, you know, the compiled application that you then test with different inputs, observe behaviors and outputs. But it's, you know, it's kind of an overall compiled application. At the level of integration component testing, you start breaking the application into pieces and testing at the interfaces. Again, testing inputs and outputs and making sure that things are behaving as they should. And all the way down to the lowest level is unit testing, the levels and functions and classes, because you can't really, you're not going to really test any lower than a function level. At that level, you can take those pieces of code and kind of simulate their environment, simulate what they expect to see, sort of make them think that they're running in the application, but really they're being tested and observed. And so that way you can really narrow down where problems might be occurring in an application. So specifically with unit testing, you're testing individual functions. And like I said, it's testing a function with a variety of inputs and observing the output and the behavior. The important thing here with unit testing is this needs to be done by the developer during the development process. So that means it's not something like, in some areas of industry, you have a separate testing group, or you have other people that you're going to pass code off to and test. Unit tests are done by you while you're writing the code. And in following TDD, it's going to be this continuous process of writing code, testing, and back and forth. So, and I'll say, ideally all functions are covered by unit tests. But the implications of what I was saying before about, how this is being written by the developer is that the tests need to be automated, quick and easy to run. You don't want to have to fire up another process, another application, and switch contexts too much. You want it to be really easy, and you want it to be fast. You don't want tests to take too long. Another thing I don't have here, I'll be mentioning later, but you don't want external dependencies on tests as well. You don't have to read and write to files or do some IO or something else that's going to add a lot of extra time. So the case for unit testing, what are the benefits? It reduces the time to discover bugs. But by following this process, you're going to be doing unit tests very often. And so this constrains the time and scope of the bugs because it hasn't been that long. If you fail your unit test today, it hasn't been that long since your last unit test passed. And so not too much has changed, and there's not too many areas, there's not too many places for the bugs to hide is the idea. And that's really helpful in, making it more, more enjoyable and reducing stress, among other things. And it builds confidence and trust in the code, not only for others in your group, which is very important, but even for you, your future self, months down, months ahead, when you come back to this code. Maybe you've gone on to something else, and 3 months later you come back to this, you forget a lot, at least I do. And so, yeah, you just kind of have more confidence that this is a reliable software when you have a lot of these tests to rely on. And the thing I skipped here, it also encourages good object-oriented design, because you have to form your software in objects, in classes. You have to do that for the tests. That also has the side benefit of enforcing, helping to have a good design for the software. So this is a diagram of basically of the TDD cycle. Sorry about that. So it's called the red-green cycle. And it starts at the red circle at the top where you're writing a test. So before you've written anything, ideally, you write your test. And of course, that test is going to fail. And the first test you write is going to be this simple thing, like you want to load this class that you're about to write. So it's going to fail. And then you'll go to the green circle, which is you write the code to pass that test. And then that test is going to pass. And then you go over to refactor. And refactoring is where now you're going to look at your tests and your code. Is there anything that is redundant? Is there something you can sort of factor out and put into a different function, into a fixture or something? There are other things like fixtures we'll talk about in a minute. But yeah, so you follow this cycle, and you just, it's short steps for each iteration through, and you eventually come up with, you've got the classes that you wanted to write, and you have tests that cover those. Okay, so unit testing in Python, we're going to talk about PyTest. which is the main way to test Python. And so basics for PyTest is this is how you install, my cursor, pip install PyTest is a common way to do it, probably the most common. There's other ways, but the pip package manager is great for all the packages and libraries that you might be using in Python. The way that PyTest works for discovery is it looks for any files that begin with test, and in those files, it looks for functions or classes that start with test. The functions are test underscore. But it makes it really easy to just, you run PyTest in your base directory, and it recurses through and it finds all the tests to run, and it just runs them and shows you the results. And you can run those command line or within an IDE. I'll show you both. An IDE is probably, an IDE is a good way to do it because, like I was saying before, it's good to have the lowest friction environment possible, where right in the place where you're writing the code is where you can click a button and you can run your tests. And one more thing before I'm going to show you some code examples, the Python virtual environment. This is something that's built into Python 3 now. A virtual environment is like, it's kind of like a container. It's this environment where you can have your packages, your libraries. You can install them in this virtual environment, and you can have it different from like your base operating system, what's installed there for Python. So it's kind of isolated. And that way you can just have this separate test environment. You don't have to worry about messing anything up, uninstalling, installing things, that kind of thing. Let's see here. I'm going to go back. Okay, so I'm sharing my console here. And I'll just give an example of doing this. So this is how I would install virtual or venv. It's telling me everything's already installed, but I'm going to create a virtual environment. Call it my_env. And so it's created that. If you go through and list, there's a lot of files that it added. But it kind of looks like a container in the way that it has like a bin directory, lib directory, these kinds of virtual environment things. The way you start this in Linux, which I'm on now, or on Mac, is you just say source, and then the name. Sorry, IVNV, bin directory, and activate. And then you can see in the prompt there, this my_env name showing you that you're in this environment. So now I can go and make all these changes, install, uninstall things, whatever I want to do, and that'll be isolated. You can run your tests in there. And the way that you leave that is you just hit deactivate and you're back. Let's see. Okay, so I'm going to open up a Python IDE called PyCharm. Let me share my screen here. All right. Yeah. All right. So this is PyCharm. It's a JetBrains IDE for Python. Of course, there are many IDEs out there. This one is pretty good. It has nice integration with PyTest. What I'm going to do is just kind of create a simple program to show the red-green cycle here. So in this project that I've create a new Python file called image_diff and another, oops. Okay, so I've given this test file over here the test_prefix. There we go. And basically that just makes it so it can, PyTest will find it and run it when we start off. So I'm in the red cycle. I'm going to write my test first. So I'm going to import this image_diff, which doesn't exist yet, but it will soon. Start my function, which starts with test_. Okay. You notice the name is kind of verbose. That's, I think, a good thing to do because it describes what the test is supposed to do, and you'll end up with a lot of tests. So, you want to keep those kind of, keep track of those. All right, so I've started a new project in PyCharm, so now I need to add a configuration for PyTest. And I'm just going to point to this test file for this simple example. But again, you can have it sort of recurse through and find all the tests and run all the tests. So now I have this environment, and like I said before, it's nice to have this environment where you're doing your coding and then you're running the tests within the same environment. So I've got this run button here, and I can get the feedback that I want, which is it's failing because there is no image_diff yet. So now we're on the green cycle of this, where I need to write the code in order to pass the test. So I'll just create this class called image_diff and then constructor for it. All right, so now if I run this, the test passes. It's a pretty simple test, but and there's nothing to refactor yet because we're just starting. And this is just a little background on this example. This is a very simple example of something that I'm using for a project where we have testing on the rendered output of this OpenGL application. It's difficult to test some of these, the rendering things. So what we do is we have this reference image, and we recreate the image in OpenGL and then use ImageMagick to do an image_diff. And that gives us, like, it not only gives you an image with red pixels where it's different, but it kind of gives you this numeric threshold. And so a lot of times, even what we consider a similar image will just have, for various reasons, have a couple of pixels that are different. So we have this threshold. If it's below, in this case, if it's below 2, that's okay. It's, we call that a pass. So that's what's going on here. Okay, so I'll just continue and add another example. Actually, I'll add some more detail to this one. So now I'm going to actually call a run compare function that will take a value and then give me a pass or fail on that. There's a syntax error there. Okay, so again, that was the red cycle, and that's going to fail. because there is no such method as this run compare yet. So I'll add that real quick. It'll accept this value. Just do simple comparison with that threshold. If it's lower than that threshold, return true. Otherwise, return false. Okay. Now, hopefully that passes. No? Oh, over here? Oh, yeah, thanks. Thank you. Okay, so now that test passes. So now I can start adding some more. Oops. I'll quickly add another one that's similar to that one, but it's going to return true when it's above the threshold. And so then if I do something like 2.1 and this one should say false. Okay, so that one passes as well. So yeah, we're still, I mean, I'm still kind of in the green part because I haven't added anything else that is going to break, nothing else that doesn't exist yet. Okay, so but now I'm going to, if you remember that cycle, there's the red and there's the green and there's the refactor. And so now I'm going to look at the test and say, okay, I've got a couple of redundancies here. They're both instantiating this image diff object. And so what I can do is create a test fixture that will initialize that, and then it'll initialize in the same way for that both tests or all the tests. Okay, so I created this fixture, and we'll talk about fixtures more a little bit later. But what I'm going to do is, in the input parameter of both of these, I'm going to say setup, and that's going to tell PyTest to, when it runs those tests, it's going to go over here and run setup first before each test. And instead of calling this directly, I need to change this to setup. So this is kind of like it is the return value of that fixture, which returns this image diff. Oh, okay. So it's telling me that PyTest is not defined. I need to just quickly include that. Okay, and those pass. So this is a really simple fixture. I mean, it's not doing much different than each one was doing before, but it's easy to imagine how, for example, sometimes you need to instantiate an object or something, and you have to do a lot of configuration or other steps to set it up. So this really helps when you start adding a lot of tests. As a final thing, I'll just do a quick example. Just kind of do a set of these values. Again, I'm going to call the fixture. So values I'll pass in, and I'll have expected values. That'll be true. true, false, false, true, and okay. Great, that passed too. Just as a sanity check, I'll make one of these really big, and that should fail. Yeah. So, yeah, this is, I just wanted to show kind of the red-green refactor cycle, kind of an example here. I'll go back to some slides. Any questions so far? Okay, so so we use the assert statement, Python's assert statement. It's not test specific, but in tests you use it to just, if it's not true, this condition is not true, then you fail the test, and that flags you that there's a problem. So there's the simple bool example here, integer, float. You can use the typical operators. pytest.approx is a nice thing to use, because with floating point values, you don't want to, compare. You're not going to get exactly in this example 0.3. It's going to be some very close number. So pytest just kind of lets you do a simplified thing without using a threshold there. Exceptions are another really important thing you're going to want to use in unit tests. So here's an example of a function under test and then the test below it, that it just verifies that an exception was raised. Keep wanting to say thrown, but exception was raised. And you can, of course, you can get really advanced with this. You can say, when the exception was not raised, fail the test, or you can count the number of times that the exception was or wasn't raised. Okay. All right, so fixtures, we saw fixtures a little bit. What they do is they can be used to initialize test functions, and you can do them simply like I showed, where a fixture is going to run before each test, but you can have them run at the top of, when a test file is opened, when a class, when the test session, regardless of how many tests. And fixtures, they're very configurable. They improve automation and avoid redundant code, and speed up tests, because you're not sort of having tests do maybe the same overly redundant steps each time if it's not necessary. Here's an example of the syntax. Let's see. So like I had before, there's the fixture. This simple example is just returning a character. You can have, there's two different ways, well, at least two different ways to invoke the fixture to start at the beginning of the test. This example here, sorry, like I did in having in the parameter list of this test, it will call that fixture before the test runs. It will also, you can also use a decorator like this and call out that fixture in the decorator, and that will run at the beginning. So test string 1 and test string 2 will run in the same way, just different ways to call it out. Here's an example of a fixture that can have setup and teardown code. So you can see the setup, the first line in this PyTest fixture setup application or setup fixture. There's also defined a teardown function, so you can have the the function within the function in Python. And so at the final line there, you're adding that finalizer. So here the fixture will run, it'll do a print setup, and it'll run the test or tests, and then do a teardown at the end, just in case you need to have that kind of level of configuration for your test environment. This is a good page for details with the fixtures. I'm actually just going to switch my screen share and go to that. So there are a lot of fixtures available. There's a lot of built-in methods that you can use, and you can have fixtures. There's a lot of built-in functionality that you can just already use instead of developing your own fixture code. So it's best to just go through the excellent Python documentation, and and then make sure that what you're trying to do isn't already done, isn't already available. Okay, so scope of the test fixtures. So I was mentioning the configurability of these before. Here's 4 examples of the scopes that you can have these fixtures run in. You can have a fixture run at the start of this session, like when you start PyTest, and that'll do a setup, and then no matter how many tests and how many different files there are, that'll just run once. And you'll notice at the end of each one of these is auto use equals true. So you can have these will just basically run, and they don't have to be called out by the test. So these are just automatic runs. So aside from the session, you can have a module, at the top of a file, and that might have many tests. Class is the third. That will automatically run there. And then, of course, you can have, like we were doing, a fixture running at the top of each test function. So test doubles, I think maybe we'll spend the most time on. Test doubles allow the unit test to run kind of in a simulated environment. They call them doubles, or they're like stand-ins for components of the code to make that unit test, the code under the unit test, feel like it's operating in a real environment. And so this diagram is trying to show how you're sort of taking it out of its production code application, linked in with all these different things, and you can simulate it under test this way. And the ways that the doubles that you can use are in alphabetical order. So the dummy is something it's just like this object that you pass around. When you have functions that are supposed to pass something, but it doesn't really matter what it is. You can just create these objects and they get passed around. A fake has maybe a little bit of functionality, but only enough to satisfy the test you're trying to do. Again, you're trying, part of the TDD is you're just doing just enough as required by the test. A mock is what we'll spend the most time talking about when we're talking about the doubles. And so this is more sophisticated behavior. You can do things like interact with simulated IO and files and things like that. And so, mocks are when you really need to do more advanced things to get your code under test to run. A SPI double is just something that, you know, is called, doesn't do anything, but it records kind of what the inputs were so that it can be used to kind of maybe take the next step in your test. Maybe you have a more advanced test algorithm where it's going to, you know, say if the object under test does this or responds this way, then I'm going to then do the next step to follow that thread of the test. And stubbing is just basically giving a canned response like yes, no, or whatever, you know, just to satisfy the object under test. So mocks, those are the more advanced things that I was talking about. I've got a list of, you know, file IO, communications, sensors. Those are things, I guess, that I've found to be handy in testing, but there's a lot more. But, you know, this is where you can really, you can mock other parts of the file system or the, or Python. You can override and change the behavior of even built-in parts of Python in order to sort of simulate what you want to test. So mocks, yeah, they make testing easy. Advantages are they make testing easy and they're fast, but most importantly in this situation is they can allow you to avoid unwanted external dependencies. So like I was saying in the beginning, you don't want to, you know, want things to run quickly. And if you are trying to read and write to files, it's going to slow down. Maybe that's not too much time, but when you have, you know, hundreds of tests, it really adds up. And I guess the psychology of this is that if a test is, if it's harder to run or it takes too long, you know, then people maybe start getting a little bit lazy and they start, you know, they kind of say, oh, I'll skip the test and skip the test. And so you don't want that. You want this smooth test cycle, and you want to avoid, you know, any friction that kind of impedes that. So unittest.mock is the default mocking framework. It's built into Python 3. It's very customizable. There are a lot of mock objects. I'll switch over to the browser and kind of show some of these, but they're very customizable. You can spec what individual interface is being mocked. So these are like function calls that you would normally call into Python, like opening a file or something. I've got an example for that. Side effects, or you can specify another function that gets called when the mock is called. And then you can also specify what you want the return value to be when you call the mock. And the information that they can provide, oh yeah, you can, like I said about assertions, you can get really advanced with which assertions were called, which specific assertions, how many times they were called or not raised, I should say. And then, yeah, there's a lot of configuration there. In fact, I'll switch back over to the browser and just go through some of those pages. So this is the unittest.mock object library. A lot of great examples in here. I think the Python online documentation is excellent. The specs, the side effects is kind of what I was talking about. Return values, these are very common, I think, to configure those. And there's magic mock, which can let you mock magic methods in Python. So you can get really into the details of these built-in functions. And there's something called monkey patch as well. I'm not able to get this. There we go. And monkey patch is another thing that's built in. There's a lot of terminology and a lot of details, but I just wanted to show these references because they're something that you probably use. All right. I'm going to switch back to PyCharm. Sorry for all the switching. I'm going to look at a couple of other tests that I've done that use mocks. We're not going to go through it like typing it in, but let's kind of show you some couple of easy ones. Here is an example of test on the right and then the code under test on the left of just verifying some WebSocket sends and receives. So here's another example of where, you don't want to have this external WebSocket server in your unit test to have to fire up, and then you can run your tests. I mean, for some testing, yes, that's absolutely. I don't want to get the wrong impression here, but for unit tests, you don't want to have these kind of dependencies. You want to be able to run them right here in the environment. And so at the right, this is just mocking up a WebSocket. On the left here, we're just doing a simple transmit. It receives a WebSocket object and it just does a send, and it sends this pause time string. But over here, we can create a mock object using async mock from unittest.mock. And we can asynchronously await this transmit, which is over here in the code under test. We can pass it this async mock because WebSocket is built on top of async. And then you can, this is another mock thing where you can look at the arguments that were passed, and then you can verify that your code was sending that string to the WebSocket. Couple things about this. Yeah, really simple example. But this, you can quickly get into situations where you want to make sure that you're sending the right information, in this case to WebSocket. Another thing to say is we're not trying to test WebSocket. We're not trying to test that library. Obviously, that's tested elsewhere, and it's been approved, and it's published and out there. So, but this is just, this is one way to use mock to do a test like this. And got another one here using mock for file IO. I'm gonna move this out of the way. Get that out of there. Okay, so this example is mocking for a test of code that uses, it's just reading from a file, reading from a configuration file and passing back data from the file. Again, we don't want to do that. It's too slow and it's external dependency. So we have these three tests here, and above we have this setup fixture. And so this first test is calling that first mock is file setup. I'm sorry, it's using mock is file. So this first test is using that mock object to just set a return value, so that when we go over here and we try to do, let's see. Yeah, when we try to create this file IO object here, we're just forcing it to say, we're testing what happens when it returns false. So we're saying it's going to return false here. Normally this code only returns false or raises that exception, that file not found exception, if the file doesn't exist. But in this case, we're just faking it out. So it's going to say, yeah, the file doesn't exist, even if it really did. And so we're making sure that we get the exception with this statement here. The next one is where we don't fake out that false return value. And so now we're just going to pass the test, and it'll fail if we did get a response saying that doesn't exist, then it would return back and say, yeah, that it actually does exist. And the reason it does is because, sorry, I'm jumping around here a lot, but the first thing in this parameter list is mock is file. So it's this setup fixture up here, and that sets return value to true, right? And it returns this config file, which is this file IO object. So the first test, we're testing what happens if the file doesn't exist and verifying we get the exception. And if it does exist, we're verifying that we don't. And this final third function, this test, is mocking this file object. So we not only fake out the open part of it, because we're doing over here when we get line, we're doing a call, the system call to file open, but we also are faking out this get line to return what we want, which is this mocked file read line. So in summary, two things. We mock the file open, so it thinks that it opened a file when it really didn't, and then we mock the contents of a fake file and pass it back and verify that it read that correctly passed back what we put in that fake file. I hope that makes sense. We can come back to that if there are any questions. Let's see. Just thought I'd give a command line example of running this as well. So I was running PyTest in PyCharm, but I can also go in to the actual directory where this example resides and just type PyTest. Get 3 green dots to show that my 3 tests have passed. If I say PyTest-V, I get a little more verbose output for that. I've got some warnings about async IO, but that's just specific to my setup. You can also do other things here. This is the PyTest-H help, but there are a lot of ways to, to configure this. A lot of settings for, like, you can say which specific tests you want to run. You can use kind of like search wildcards, to get kind of test subsets that you want to run. Yeah, just a lot of configuration there. And with PyDev too, I showed just PyDev. Another popular IDE that has nice PyTest integration is Eclipse. There are a lot of Python IDEs to use. Let me share this one. Okay, so this is kind of just getting to the end. just a few best practices things here. I think I said this before, but use good naming for tests because you'll have a lot of tests. You have all these files and you want to have a nice readable explanation about what you're testing. Because again, it's not just you who's going to work on this. When you pass it off to someone else, it's easier for them to understand what's going on. Writing tests in order of increasing complexity is good to do here because with that red-green refactor cycle, is if you start with the easy stuff, it's easier to catch that redundancy and start making these fixtures that capture redundant code, or you kind of start seeing that, oh, I'm going to need to do this setup. I've not only done it a couple of times already, but I'm going to need to be doing this for future tests. And it just, it's a nicer test flow that way. Process of running tests needs to be accessible and easy. I've talked about that a lot, and running as fast as possible. Yeah, again, external dependencies. These kinds of things are like, especially when unit tests start to fail. I talked about the psychology a little bit. You know, it gets to be easy to kind of brush off a test that doesn't work anymore and think, oh, that's broken, I'll fix it later. And then after a while, you know, your unit tests haven't run for a long time, and you know, they start getting neglected, and now it gets harder and harder to go back and, you know, add them because you've got more and more code that doesn't have good test coverage. So, you know, all these things, the fast and easy, it's just kind of part of what I think keeps it running smoothly and keeps people from neglecting. This final thing here, what I mean by that is you just want to test, you want to test the behavior. You don't want to think too much, or try not to think too much about how you've implemented it, because for one of the reasons is, you know, you're not going to be the only one maybe who's going to work on that. And it's possible for you in the future or someone else to break a test when it really shouldn't break, because, you know, the behavior is okay, but the test failed because, you know, maybe another developer did it a different way, you know, but that's okay because, you know, the requirements of whatever your software is are not necessarily how it's done. They're just, you know, meeting expectations of output and behavior. And I think that's the last slide. Yeah. So thanks for listening. I'll open it up now to questions. And like I said, just you don't need to raise your hand on Zoom. You can just kind of chime in whenever if you want.
Thanks, Gene.
Yeah.
Have you ever tried using the hypothesis library? I was wondering if you had any thoughts or experiences on that.
No, I haven't.
Oh, I highly recommend it. That one's another test library. And what it does is it lets you it'll auto-generate parameters to functions, and with increasing complexity. And then when it finds an error case, it'll start simplifying the parameters to the function and then hand you back a reproduction case in a simplified way, saying, you know, I performed these sequences of events, and this was this, you know, so say you're doing like intersection of a polygon, a line through a polygon. And so it would build polygons and throw it at your, you know, line intersection test until it found a failure. And then it can remove vertices from the polygon automatically and then hand back, this is the simple polygon that has a failure in the case. And I haven't tried it much. I've done it a little in Python, and I haven't gotten as sophisticated with it in Python. I was just kind of curious if just if you had any knowledge on that.
Sorry. Yeah. Okay. Yeah. Ross was just saying it's kind of fuzz testing.
Yeah. And I forgot the name. It's not parameter-based testing is the style, I believe, is the technical name.
Yeah. No, it's hypothesis, you said?
Hypothesis is the Python library. And parameter-based testing is the field of discipline, I guess, or whatever. It came out of Haskell or something, I think, a long time ago. There's a really good talk online on it, but I don't know. I've had a lot of success for it in some areas, but like I said, I've been struggling a little bit with the Python implementation. So, but I think that's just me, not anything to do with the library.
Oh, that sounds great. It sounds like a great way to really blast the code with a lot of possible combinations there.
Yeah.
Let's see, there's something in the chat. Just thinking. Anything else? All right, well, thanks for attending.
Oh, thank you.